we've covered this before. In fact, we covered it last year quite early on, which is one of the reasons why I want to revise it with you, because it comes under, as well as your previous topics on storing and retrieving in the prelim course, it also comes under multimedia, which is one of the big topics that's being assessed in this upcoming exam. Okay, so if you get a better refresh your memory because it's been a while. Do note, by the way, that this says calculating. It does not say evaluating. So that's why in the actual HSC, not only do you not need a calculator, but you actually cannot bring a calculator in. The point is not to get a final number at the end that it's, you know, this many megabytes or something like that, but just to show the process that you go through in actually working out, okay, well, how big is something? Okay, now just for the sake of it, I am going to work these numbers out, even though you don't have to, just so that you can see, like, okay, are we in the right ballpark? Do these numbers make sense at all? Okay, so we'll get onto that in a minute. Now, under multimedia, there are three kinds of file type whose size we're interested in calculating. What are the three?
Video.
Okay, video. And image. And audio. Okay, now, I'll take it in reverse order. We'll go from simplest to most complex. Remember, by the way, that all of this is considering it as uncompressed, because there are so many different varieties of compression out there, and compression works so differently based on the kind of data you have in a specific photo that you can't reliably know what something's image size or audio size or video size will be after compression. It's worth noting that for things like, say, MP3, that's an audio type of compression that it's generally speaking about a 1:10 ratio. So if you had, say, a 40 meg WAV file, that'll usually come out to be about a 4 meg MP3 file. But that kind of idea, like estimating compression and that kind of thing, doesn't really come under this heading. This is just working out precise, you know, for a bitmap image or for a WAV file or for an uncompressed video. Okay, so the numbers tend to be pretty huge. All right, let's start with images. Now, let's see how much of this you can remember. There are only really two things you need to know, two quantities about an image that'll tell you what its file size should be. This is just uncompressed, right? Does anyone remember? What are the two things you need to know? Yeah?
How many bit depth?
Okay, number one, bit depth. So that's a way of saying how many colors does something have, right? Because each individual pixel, bless you, will have a certain number of bits assigned to it, right? And obviously, the more bits you can have, the more color combinations, okay? So there's the first thing. What's the second thing? Good. So resolution. If bit depth tells you how much space each pixel takes up, you need to know how many pixels there are as well, and that's resolution. Okay. So just a really simple example. Suppose we want to find out, e.g., okay, calculate the size in kilobytes. Okay. Note the units. That'll be important in a second. Of an uncompressed bitmap that is, say, well, let's imagine, say, the resolution of an iPad screen, which is 2048 by 1536. Okay. So, how do we do it? Well, let's see. Hold on. I'm missing something, which is bit depth. Okay. So, what's the usual bit depth for an uncompressed bitmap? Don't know. Now, there's a couple of ways you can think about it, right? You can think, how many colors are there? How many colors? Or just what is the actual number of bits? Now, the standard number of colors for an uncompressed bitmap is 16.7 million. Okay? Warning. So how many bits are required to get that many colors? Yeah, Dan? You're right? Oh, okay, that's fine. It's 24. It's 24. So let's go 24-bit color here. Okay. So, like I said, images are pretty simple, right? It's just going to be this part and this part. But the only thing you need to be really conscious of is this conversion to this unit. Okay? So here's what your answer would look like. Your answer would be And it's going to be a fraction, and I'm going to try and outline the different parts of it in a second. It's going to be 2048 by 1536 by 24. So all of that you just got straight out of the question. But remember what this is going to tell you is this is in bits, but we want it in kilobytes, right? So how do I convert from bits to kilobytes? Well, first, to go from bits to bytes, how do I do that? I divide by 8, right? And then you go from, now I'm in bytes, to go to kilobytes, I have to divide by 1024, good. Which is 2 to the power of 10, okay? So just to make sure you know what each component refers to, right? Here's your resolution, okay, the number of pixels. Here's your bit depth. Now since that's in bits, this converts into bytes, and this converts into kilobytes. Pretty simple. Okay, now just for the sake of it, like I said before, let's work out what that is. That is 2, 4, 6. Okay. Now I get, oh sorry. Let's see, did I calculate this right? I got 9216. Does that seem about right? It's like 9 megabytes. Is that about right?
Why does this say?
Yes? Do people think it makes about sense? It does. I mean, the reason why it seems like that's so huge is because it's uncompressed. We're used to taking pictures and they're compressed as JPEGs, but there's still like a few megabytes a piece, right? So this is actually in exactly the right ballpark. Kilobytes. Okay, but anyway. You didn't actually need to work that out. This part up here, that's the important bit.